8.3 is about inverses of relations. It's something that we touched on yesterday with 8.2, and this is just looking at the part where we did equations. And here's kind of the back up. The notation. I've mentioned this before in the notes that when you have f, well, normally we have things like f of x. If you're getting the inverse of that, then you add that little -1. So if you have f of x, this here would be read f inverse of x, or given this original equation, this is going to be the equation that undoes it, what the first thing does. And we'll see that more in the notes today. So the steps. We did this yesterday. Substitute y in for f of x. F of x is just a fancy way of saying y. And then we switch x and y. Now 3 and 4 are going to be the two new parts in this section. We actually now, once we switch x and y, we go back and we solve for y, so we end up with y equals. And then we kind of undo what we did in this first step, where we took f of x and changed it to y. Now we take our new y and we change it to f inverse of x, because x and y were switched. So I want to do those, have a couple examples here. So let's just go through into the steps. First step, f of x, we just change that to a y, because that's a fancy way of writing y. So it becomes y equals 3x plus 5. Once we have that, now we switch x and y. And once we do that switch, we're technically working with the inverse right now. But to put it in the proper form where we can change it to this f inverse of x notation, now we need to solve for y. So we go and do what you've been doing for years. We do order of operations backwards. We start out by subtracting 5 from both sides. You get x minus 5 equals 3y. Then y is multiplied by 3, so we do the inverse of that. We divide by 3. Now we're left with y equals, I'll rewrite it, y equals x minus 5 over 3. And now our last step, now that we have this new y, we change it to f inverse of x equals x minus 5 over 3. Every year there's some people that decide not to do the steps, and sometimes it works, sometimes it doesn't, but they'll look at this 3x plus 5, and the most common answer I'll get is they'll say, well, the opposite of adding 5 is subtracting 5, so they change that to a minus 5. Opposite of multiplying by 3 is to divide by 3. So they'll write this down as their answer. But if you notice, that gets the order of operations in the wrong order, because it needs to be subtracting 5 before you divide by 3. So I would encourage you to do the steps, or at least think real hard about it and kind of figure it out on your own without needing the steps. Next example, I have f of x equals x divided by 4 minus 9. Find the inverse. So we go through, and step number 1, change the f of x into a y. What you might want to do even is do this on your own and then just quick scan ahead in the notes, see if you have the right answer, and if you don't, then kind of follow my steps. But I'm going to work through it. So next step then is that we want to, next step is to switch x and y. So x equals y divided by 4 minus 9. Now I can go through and add 9 to both sides. And I get a x plus 9 equals y divided by 4. And now I multiply by 4 to get y by itself. When I do this, it's tempting maybe to just write 4x plus 9, but we had this x plus 9 here. We need to multiply the whole side by 4. So you end up needing to do distributive, and you get 4x plus 36 equals the y. Final step, change this y back to the inverse notation. So the y becomes f inverse, f little -1 of x equals 4x plus 36. That's my second example. One more example for you. I want to kind of try to throw another trick in there. And this one I have this x to the 7th power, so we can kind of mess around with that. So first thing, we change the f of x to y. And once you get comfortable, you can combine the first and second step. If you know what you're doing, just don't start making mistakes because you're trying to make the problem too short. But then we go through and we switch x and y, which then makes it the inverse. Now we want to solve for y. So the first couple steps look the same. We subtract 4, and I get an x minus 4 equals 5y to the 7th. Now we did our adding and subtracting, so multiplying and dividing comes next when we're solving for a variable. So we'll divide by 5. X minus 4 divided by 5 equals y to the 7th. There's a couple ways to write this. The way I prefer, we haven't talked about yet, actually I mentioned it briefly in the notes, but to get rid of a 7th power you take it to the 1/7 power. That's the part we went over in the last chapter. And then that cancels out the exponents, leaving us just y equals this whole thing here on the left. So I'm going to do that last step and change my y back to the Euler's notation. So f inverse of x replaces my y. Then it equals this here, x minus 4 divided by 5. That whole thing, the 7th root, or to the 1/7 power. If we haven't talked about it yet, but you could rewrite that right side this way if you wanted to. Just make sure that that whole fraction is inside the radical. But that'd be another way you could write this example. Alright, the second part of the notes is Roman numeral 2, working with inverses. And this is going to look similar to something we did earlier, the composition of functions. That we have now two equations. One is going to be f of x equals 3x plus 5. The other one is f inverse of x equals x minus 5 divided by 3. And these two should be inverses of each other. They have the same name, the f of x, but one is the inverse. So if we do this, we always start in the inside of the parentheses. That's what we said. So when we have this one here, we go over to this red equation because it's f inverse. 3 is in the same spot as the variable, so we replace the variable with a 3. So this interior part then becomes 3 minus 5. I replace the x with 3, divided by 3. And then we still have to do f of that. Well, 3 minus 5 is negative 2, so really this becomes f of negative 2 over 3. And now we just have our f function, so we take and put this into our f equation. So we replace the x with negative 2/3. So this then becomes 3 times negative 2 over 3. And we still have this plus 5. Well, my 3's will cancel here. Negative 2 plus 5 equals 3. And jump down to the second one. I have similar, but now I'm doing them in the other order. So I start with function f. So I take my 5, it's in this x spot, so we replace the x with a 5. So I get 3 times 5 plus 5, which then equals 20. So I still have my f inverse. Let me throw that in there. So the problem becomes f inverse of 20, and now we're halfway done. Other than f inverse is really sloppy. Now I take my 20, and now I'm doing my f inverse function, so I put a 20 in here for x. Whatever's in the parentheses replaces the variable. So I get a 20 minus 5 divided by 3, and then that gives me 15 over 3, which is 5. Alright, so numbers, hopefully that makes sense, kind of a good review of a section we did earlier. The next two are real similar, but if you notice, now I'm just doing variables. And that messes with some people. But if you notice, this f of x here is the same as f of x. So we could just say, well, f of x equals that. So I can replace what's inside those parentheses with 3x plus 5, because that is equal to f of x. So I have 3x plus 5 goes there. And now I still need to do my f inverse of that. Now I take my 3x plus 5 and I put that into my f inverse function. So this x here, because 3x plus 5 is right there in the parentheses, it replaces this x. Doesn't matter that there's an x in it, whatever's in the parentheses, so this here has to replace my variable. So it becomes 3x plus 5. That goes in for my x. Now I subtract 5 from it, and that completes my numerator. And all that's divided by 3. So my plus 5, my minus 5, those just cancel. I'm left with 3x over 3, which equals x. And I'm hoping that you notice something. And maybe I'll kind of pause briefly. If you look at the problems up above, what do you notice when you do a function and you do the inverse? Well, if it doesn't jump out at you, here we have a 3. We did the inverse, we did the function. These two undo each other. We ended up with a 3. This one here, we started with a 5, we did the function to it, then we did the inverse. Those two should undo each other. And sure enough, we end up right back where we started. Same thing here for x. We did the function, we did the inverse. These two undo each other. We end up with the x. So a wise person would guess that looking at this here, if we take an x, we do the inverse, and then we do the function, we should end up with x. And I'll quick go through and do it just because it's a good, well, it's good practice, and it kind of proves the very last point we have in the section. If we have this f inverse, so that was our x minus 5, all divided by 3. And then we need to do our f function to it. Our f function was 3 times whatever's in the parentheses, so 3 times x minus 5 divided by 3 plus 5. Now, when I do distributive here, my 3 times my parentheses, the 3's just cancel out. X minus 5 plus 5 just gives me an x. And the reason I point this out is the very last thing. Technically, if you want to determine if two things are functions, what you have to do is you have to take your two equations and you have to do the function and the inverse, and then the inverse and the function. You have to make sure that it works in both directions, that if you start with x, you end with x. And that's the very last thing we have in the notes, which should be showing up here, and it's not. Well, that's professionally embarrassing. I'll write it out. Let's write it up here. So we could say if f and g are functions, such that f of g of x equals x, and we do them in the other order, g of f of x equals x, then f and g, or f of x and g of x, are inverse functions. The book has at least one question where it's saying, are these two equations inverses? And technically what you have to do to prove it is what we just did in these last two examples. This one here and that one there. And that completes the notes on 8.3.